Howdy folks, Mr. K here with a lesson on ionic bonding. So, before I get into what ionic bonding is, you must, if you don't remember how ions are made, you need to go watch my video on ion formation first, because I'm going very quickly over a lot of background information. My ion formation video does a much better job of going over it than this one will. So, let's get into it. What the heck is an ionic bond? So, an ionic bond is the result of an electrostatic attraction between cations and anions. So, you gotta remember back to the octet rule. Every atom wants 8 valence electrons. Metals, like sodium, want to give away their electrons to nonmetals like chlorine. By doing this, sodium gets a full octet, meaning it has 8 valence electrons and has completely full s&p orbitals. And chlorine, by receiving that 1 electron, gets its full octet and a full s&p orbital. And after that happens, whenever an atom gives away an electron, it becomes positive. So this positive means +1. Sodium gave away 1 electron. So it has 1 more proton than its electrons. And this negative right here means gained 1 electron. And sodium chloride, remember it's table salt, there's a bond between these two right here. This bond, it's a bond because the positive sodium is attracted to its opposite, the chlorine. Or the sodium cation is attracted to the negative chlorine anion. So if you were to take a little shaker of table salt and zoom in so close you could see the atoms within the salt crystal, this is what you would see. You would see negative chlorine ions, shown in green, stacked right next to positive sodium cation. An ionic bond is the result of an attraction between a positive ion called a cation and a negative ion called an anion. Now, even though an ionic bond is made out of ions, the total charge of the compound, the ionic compound, has to be 0. So elements bond together in specific ratios so that the total charge, meaning the total number of electrons given away by the metals, is equal to the total number of electrons gained by the nonmetals. For example, potassium and oxygen bond in a 2-to-1 ratio. It's 2-to-1 because it takes 2 sodiums giving away 2 valence electrons to the oxygen to make it even out, so that oxygen has its full octet and potassium has a full octet. There's an easier way than looking at the charges to figure out what the formula of an ionic compound would be. It's called the swap method. In the swap method, we take the superscripts that we use to show as charges and swap them to become the subscript on the neighboring anion or cation. For example, let's say I had iron 3, which has a charge of +3, and oxygen, which has a charge of -2. Instead of having to sit here and go, okay, I need to make the ionic bond equal 0, so it's going to take 2 ions to give me a total charge of +6, and 3 oxygens to give me a total charge of -6, so it evens out. Notice I could just swap them. Just the 2, not the minus. The 2 becomes the subscript on the iron, and the 3 becomes the subscript on the oxygen. So Fe2O3. And whenever you do this, sometimes when you do it, for example, let's say we're doing calcium and oxygen, which is +2 -2. When you swap these, you would get Ca2O2. But you can't leave it like that. Just like in math class, you have to reduce to the lowest value. Same thing in chemistry. You can divide both of those subscripts by 2. So they just become subscript 1. Notice you never write a 1 when writing a formula. It's only numbers greater than 1 when it needs a subscript. Now, it's not enough to know how an ionic bond is made or how to write its formula. You also need to be able to name it. But it's very simple to do that. It's 2 simple steps. First of all, write the name of the cation, or the metal, as is from the periodic table. If it's a transition metal, make sure you include a Roman numeral to tell you the charge on that transition metal. Then, you write the name of the anion, but you change the last 2 letters to I-E. For example, NaCl. Na is sodium, so we write sodium. And Cl is chlorine, but we don't write chlorine. Step 2 says we have to change it to chloride. Fe2O3. Fe is iron, so we write iron. We have to include a Roman numeral 3 because iron is a transition metal. We don't know its charge without the Roman numeral. But we don't write oxygen for the O, we just write oxide. And then another example, MgF2, magnesium fluoride. Now you're going to find sometimes not everything is a simple binary ionic. Sometimes you have something called a polyatomic ion. You'll see more than 2 elements within an ionic compound. That's because there's things called polyatomic ions. There's like a whole list of them. Basically, polyatomic ion is like a compound that carries a charge. For example, NH4 is the compound, is this. It's a nitrogen with 4 hydrogens. But not every electron is evenly shared, so the entire compound moves as a unit and has a charge of -1. There's other ones like sulfate, SO4 -2, or carbonate, CO3 -2. You'll find a whole list of these on the back of your star materials. There's another simpler list. Notice there's more than one type, and there's more than one charge. Charges ranging from +1, notice the only +1 is ammonium, to -1, -2, or -3. Also, you need to pay attention to this. Right here, look at this. Nitrate and nitrite. 2 completely different ions, one's NO2, one's NO3. And you also need to know that nitride would be like N3 minus. Here's another one. Chloride, chlorate, perchlorate. Sulfite, sulfate. Chromate, dichromate. You need to pay attention to the names listed and the elements within the formula, or you'll mess it up. Naming polyatomics is very simple. It's almost the same. I mean, the formula writing is pretty much the same. You just have to move things as a group, and the naming is slightly different. The only difference is when you get to the polyatomics name, you just write it as is. You don't need to change anything. Still the same thing. Name the cation first, and then the polyatomic name. Or in the case of ammonium, just write ammonium, and then the anion change to IE. Okay, folks, that is everything you need to know about ionic bonds. I will see you in class.